Okay, so we are on question 8 of the Mathematics Higher Level Paper 2 August 2020 Khomas Region Exam. So let's go down all the way to question 8 and let's see what we have here. Okay, it says consider the line y equals 2x plus a half and the curve y squared equals 4x. Now which of the following statements are true? A, B or C applies. Okay, so the line is either a tangent to the curve, or the line cuts the curve in two distinct places, or the line neither cuts nor touches the curve. Okay, so to find out where two curves cross each other, the line and the curve, where they cross, we can set them equal to each other, right? So if we set them equal, let's start by doing that. So we already know y equals this, so instead of the y here, we can substitute 2x plus a half, because that is y. So we can say 2x plus a half squared, y squared, equals 4x. Okay, let's just multiply this out to see what we get. Okay, so if we multiply this out, so 2x times 2x is 4x squared, 2x times a half is x, times 2 is 2x, and a half times a half is a quarter, equals 4x. So let's just collect all the like terms. That means we've got 4x squared, and then we've got 2x minus 4x, so minus 2x, and plus a quarter, equals 0. So we see here we've got a quadratic equation. And now to know the values of the quadratic equation, or to solve for that, we can say we know that if we have a tangent to a curve, if it only cuts at one spot or just touches, then our discriminant, or delta, is equal to 0. If the line cuts the curve in two distinct places, so if we have two roots, then our delta is greater than 0, and if we don't have any roots, if it doesn't touch or cut the curve, then our delta is less than 0. So this is what we'll be working with. And I suppose this is probably the part where most students would probably get stuck, not thinking that we could use the idea of roots and where things cut to use this delta equation, and the delta formula, discriminant formula, to find out whether A, B or C is true. Okay, so let's work out what our delta is in this case and see what that gives us. So that is b squared minus 4ac, and let's plug those values in. So b in this case is negative 2, so we have negative 2 squared minus 4 times a, and a in this case is a 4, and our c in this case is a quarter, oopsie, 1 over 4. And what does that give us? Negative 2 squared is 4, minus, and 4 times 4 is 16, times a quarter. So that gives us 4 minus, and 16 times a quarter, or 16 divided by 4 is 4. So our answer is 0. So which one is that? Number A. So the line is a tangent to the curve. So let's just write down A. Line is a tangent to the curve. Alright. Question 9. Solve the equation tan 2x equals a third, giving all the values of x in the interval from negative 180 to positive 180 degrees. Okay, so let's start by just rewriting our equation. So tan of 2x equals 1 over 3. Alright, now we want to find our reference angle. So our reference angle is arctan, we also call it shift tan because that's what we press in the calculator, of 1 over 3. And let's work out what that is. So, oh yeah, this calculator can't do that. I think I already worked it out over here. So arctan of a third is 18.4 if we round off to one decimal place for angles. So 18.4. Okay, so that gives us 18.4 degrees. And now let's use our cos diagram. So here we have 180 plus goes that way, negative goes that way, and here we've got 360 minus for this quadrant. Alright, so we saw tan was a positive value. So where is tan positive? Well, tan is positive in these two quadrants. Okay, so that's in the first quadrant and the third quadrant. So for the first quadrant, we can just keep the value as it is. So in this case, our angle is equal to our reference angle, 18.4 plus, and then the period of tan is 180, so every 180 degrees we will get the same value. So that's why we say plus 180k for every whole number or integer value of k. Oops, integer value. So integers are given by the z symbol. And now the thing with tan is you only have to do actually one of the two quadrants, because if we draw a line here and we go 180 degrees from there, we hit the other point as well. So we can just go 180, another 180, or we can even go the other direction, negative 180, negative another 180. So that's fine. So we actually just need the one thing for tan. And then to get x by itself, which is what we want, we divide everything by 2. So x equals 9.2 plus, and then 180 divided by 2 is 90 times k. And we're still looking for all k values that are integers. So we can do full revolutions, 180 positive in that direction, or negative 180s, as many times as we want. Okay, so let's check which values of x will satisfy this. So x will be equal to, so we've got 9.2. 9.2 works because that's between negative 180 and 180. Then let's say we add another 90 to it. So if we make k 1, it would be 90 times 1. So 9.2 plus 90 would be 99.2. And that's fine because that's still between negative 180 and 180. Now if we add another 90 to this, we get 189.2. So that's too big, so that doesn't count. Now let's start from 9.2 again, and now let's subtract 90. So 9.2 minus 90 is negative 80.8. Okay, let's just make sure about that. Actually, yeah. Let's do, what do we do? 9.2 minus 90. So that gives us negative 80.8. That's right. And then we can say, let's subtract another 90. Minus another 90, you get 170.8, negative 170.8. So that's still also fine. Negative 170.8 is still between negative 180 and 180. If we subtract another 90 from here, we get negative 200 and something. That's too small. So these are all the values we want. And I'm just going to write them in order from smallest to largest. So I'm going to start with negative 170.8 degrees. Then we've got negative 80.8 degrees. Then we've got 9.2 degrees, and finally we have 99.2 degrees. So those are all our values. Now if you did both quadrants instead of just the one quadrant, that would work out to the same thing, right? So this would be for our quadrant 1. And if we did quadrant 3, then we'd say that 2x is equal to, this is 180 plus, so 180 plus 18.4, that's 198.4. Okay, plus 180k, where k is an element of the integers. And if we divide this by 2, we'll get x equals, and what is 198.4 divided by 2 gives us 99.2. So 99.2 plus 90k, where k is an element of the integers. And we see 99.2 is one of the ones we want. So if we just subtract 90 from there, we get this one, subtract 90 again, we get that one, subtract 90 again, we get this first one. So we see it will work out. If you did both, that's fine, no problem. And the nice thing about tan, though, is that we just need to do one of them. We only have to work with one of the quadrants. All right. Question B. Solve this equation. Okay, between 0 and 2 pi radians. So I would suggest, because we work with degrees most of the time at school, let's work it out in degrees and then just convert the final answers back to radians. Okay, let's start by rewriting the equation. So 2 cot squared x plus 3 cosec x is equal to 0. Okay, and since our calculators don't have cot or cosec, and we want all of it to be the same, so either sin or cos or tan or cosec or cot or whatever, then we can just, I prefer to just convert everything into sin and cos to start with. So I'll say for cot, we'll have 2 cos squared x over sine squared x plus, and cosec is the same as 1 over sin. So we've got 3 over sin x equals 0. Now let's get a common denominator here. The common denominator would be sine squared x. Over here, this is already fine. Doesn't need anything added. This 3 though, this thing has to be multiplied with sine x. So we have to multiply with sine x equals 0. Now if we multiply both sides by sine squared x, this goes away, and 0 times sine squared x remains 0. So this is our equation right now. 2 cos squared x plus 3 sine x equals 0. But like we said just now, we want everything to be the same kind of ratio. Not cos and sin, but just cos or just sin or just tan. And what a bargain. We've got a cos squared here, so we can change that into a sine in some way. So we can say cos squared is the same as 1 minus sine squared. And then plus 3 sine x equals 0. Let's multiply this out, so we get 2 minus 2 sine squared x plus 3 sine x equals 0. Okay, so we can see this is a quadratic trinomial. So let me just rewrite it with a positive first value. So I'm going to put the 0 here, equals, take this over, becomes 2 sine squared x minus 3 sine x and minus 2. Alright, so this one, oh nice, it can factorize. Okay, so what we can do is we can put our two brackets. This will be a 2 sine x. This will be just sine x. And we need negative 3. So if we put minus 2 here, we've got negative 4 sine x. And then we add 1 sine x to get us to negative 3 sine x. Great. Okay, so from here, let's just move all the way up here and start from there again. So this bracket is 0 or this bracket is 0. So the first one, 2 sine x plus 1 equals 0. Let me just write all of that down. 2 sine x plus 1 equals 0. So that means 2 sine x equals negative 1, which means that sine x equals negative half. Great. And for the other bracket, we've got sine, I'm just going to write that down a little bit lower. Sine x minus 2 equals 0. That means sine x equals 2. Okay, so something you can see here is this will be not applicable. Right? Why? Because if we look at the sine graph looks like this. Right, and it keeps going forever. Oh, that's really ugly, but it keeps going forever. Although we know the maximum value it can be is 1, the minimum value it can have is negative 1. So sine x equals 2, that's impossible. So that's why this is not applicable. Alright. And you'll also get an error if you type this in your calculator. If you type shift sign of 2, you should get an error for that, which tells you it is not applicable. Okay, so we need to work with this part. So here, let's find our reference angle. So our reference angle is arc sine or shift sine of a half, and that equals 30 degrees. Okay, now let's do our Cartesian plane. 180 plus, 180 minus, 360 minus for our quadrants. Okay, we saw sine was negative, right? Negative half. So where is sine negative? Well, in this quadrant and in this quadrant. So we're going to be working in the third and fourth quadrant, which is 180 plus and 360 minus. So for the first one, so we'll have x equals, and then 180 plus for this quadrant. So 180 plus 30 is 210 plus 360k, where k is an element of the integers. And then for the fourth quadrant, we'll do 360 minus. So this will be 360 minus 30, which is 330. Plus 360k, k is an element of the integers. Yeah, why do we do plus 360k? Because 360 degrees is the period of a sine function. So every 360 degrees will have the same value again. Just like we saw earlier, the sine graph goes on forever in this fashion. So let's say if we had this value here, then 360 degrees later we have the same value. Another 360 degrees later and we'd have the same value again. So that's why we do 360k. Alright, so this is our general solution. Now we need our specific solution. So between 0 and 2 pi, so convert this to degrees, that'll be 0 degrees, and that is 360 degrees. Okay, so from 0 to 360, those are all the values we need. So let's say, so x equals 210, and if we add 360, we get 570, that's too big. If we subtract 360, we get a negative number, so that's it for this part. Or 330 is fine. If we add 360 to 330, we get 690, that's too big. If we subtract 360, we get negative 30, that's too small. So that is it for this one. Now we need to convert these two values back into radians, because our question was asked in radians. Okay, so we know pi radians is the same as 180 degrees. And we have the degrees, so we want to find the radians. Okay, let's cross multiply. So 80 times x times 180 is 180x, and then 210 times pi is just 210 pi, and divide by 180. So we get 210 pi over 180, and we can simplify that slightly to be 7 pi over 6. Okay, so there is our first value, 7 pi over 6. Then we can do the same thing for the 330. So we know pi is the same as 180. We don't know the radians, but we know the degrees is 330. And again, we can cross multiply. So 180x is equal to 330 pi, and divide by 180. So we get 330 pi over 180. And that gives us, if we simplify this, divided by 30, we get 11 pi over 6. So 11 pi over 6. Good, so those are our two answers here. Very nice. Okay, that's it for question 8 and 9, and then we'll have a look at question 10 shortly.